NASA-funded scientists estimate that the volume of water molecules locked in minerals in the moon's interior could exceed the volume of water in the Great Lakes here on Earth. Scientists at the Carnegie Institution's Geophysical Laboratory, along with scientists across the nation, determined that the water was likely present very early in the moon's formation history as the hot magma started to cool and crystallize. The result means water is native to the moon. It's found in its structural form hydroxyl, a very minor component of the rocks that make up the lunar interior.
Yeah, I'm going to step off the limb now. That's one small step for man, one giant leap for mankind. That's a good step. Yep. About a 3-footer. Beautiful view. Isn't that something? Magnificent sight out here. Magnificent desolation.
How is the quality of the TV?
Oh, it's beautiful, Mike. It really is.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface.
Up now, and you can see the stars and stripes on the lunar surface. Beautiful, just beautiful.
Hydroxyl is OH, and we all know that water is H2O. So somewhere along the way, hydroxyl, which was originally water, lost an H. Well, that process occurred billions of years ago when the moon originally formed. And so the measurements that they're making now, finding these very small, incredibly tiny amounts of hydroxyl, tell us a lot about the amount of water at the early formation stage of the Earth and the Moon. Well, this is not really H2O, water that we know. So it's not like it's pools of water or even ponds of water. It's actually ancient water that has been modified in the solidification process of the Moon during the time of its early formation. What's really exciting about these observations is it's allowing us for the first time to understand what the conditions of the early Earth was when the Earth and the Moon were formed together from a collision from a Mars-sized object that hit the Earth 4.5 billion years ago. Well, there's been quite a bit of talk about how did the Earth get the water that it has. Did it begin that way, or did the comets bring it in, or even the Kuiper Belt objects bringing water in? And so this is now the first evidence that we had that there actually was a fair amount of water initially in the Earth-Moon system 4.5 billion years ago. What these scientists discovered by examining specific lunar rocks, and these lunar rocks are called apatite. And apatite is one of those, as it forms, it grabs water. Now it did that in its early formation, 4.5 billion years ago. It liberates the hydrogen and leaves what's called hydroxyl, an OH molecule, stuck within its crystalline structure. And so the scientists with instruments that are far better than we've ever had before were able to detect apatite, within the apatite, this hydroxyl at parts per billion. And that tells us a lot about how much water was in the early Earth formation.